Hello, Professor. My name is Kumodini, and today I will be showing you a walkthrough of my Lab 3 for DPS912. In this lab, I implemented a C++ program that uses IOCTL system calls and sockets to retrieve network interface information such as the IP address, MAC address, netmask, and broadcast address. So now let me quickly show you how this program works. So I will open my terminal and run make to compile it. So inside my directory, I have the two files finished. So now when I run the command make, as you can see, it compiles cleanly with no errors. Now I will run the program with /either control. So as you can see, it asks me for an interface name. So I will enter ENS33, which is my main VMware network interface. So now I will go through each menu option. So if I press enter for one, it provides me with the MAC address. For option 2, we have the IP address that looks like this. And for the network mask, this is our network mask. And for 4, the broadcast address. And if I click enter or to exit, I will exit the program. So now let me run ifconfig so we can compare. So ifconfig. This shows me why my values, as you can see, all 4 values match exactly. So now let me run it again with the loopback interface. So since I want to run for the loopback interface, I'll press LO. And let me see, if I press option 1, it tells me that it's not an Ethernet interface because it's not. And the IP address is 127.0.0.1. And the netmask address, which is the third option, 255.0.0. And the fourth one, the broadcast address, is 0.0.0, which is expected since loopback does not support broadcasting. So if I exit and if I go through my values of ifconfig, you can see that the values do match for the loopback as well. So finally, let me walk through the code that I have. So this is my code. At the top, we have the necessary headers included, things like sys/ioctl.h for the ioctl calls, net/if.h for the ifrec struct, and arpa/inet.h for the inet_ntoa function that converts addresses to readable strings. So the program first prompts the user for an interface name and stores it in the ifrec structs ifr/name field. Then we create a socket using afinet and sockdgram. This is not for sending the data. We just need a valid file descriptor to pass to iOS control. The menu loop then runs, and depending on the selection, we call the IO control with a different request code. So for the IP address, we use this. For the network mask, we use this one. And for the broadcast, we have this. The result comes back inside the ifrec struct, and we cast ifr/address to sock address in pointer to extract the IPv4 address, which inet/ndoa then converts to a string. So one challenge that I faced was understanding why we use a sock-3gram socket just to call IOCTL. It seemed odd at first since we're not actually sending any data, but after researching I learned that IO control requires a socket file descriptor as a handle into the kernel's network stack, and AF-INET with sock-dgram is the simplest way to get one without needing special root privileges. Another small challenge was the loopback broadcast result. I initially was not sure if getting 0.0.0 was an error or correct behavior, but I confirmed it's expected since loopback has no broadcast address. So now let me also show you my makefile function, makefile code. So this makefile is used to automate the compilation process so we don't have to manually type the full compiler command every time. So it uses the G++ as the compiler with the wall flag to show all warnings and G to include debugging information. The default all target builds the executable named either control from the source file either control.cpp. A clean target is also included, which deletes the compiled binary using the rm command, allowing us to do a fresh rebuild whenever needed. Running just make in the terminal is all that is required to compile the entire program. So overall, I believe that I've met all the requirements of this lab. The program correctly retrieves all 4 pieces of network information. The output matches ifconfig for both ENS33 and loopback, and a working makefile is included. I handled edge cases like loopback and non-Ethernet interfaces gracefully, so I would evaluate myself 9 out of 10 because everything works as expected and I have a solid understanding of how IOCTL and sockets interact at the system level. Thank you so much for watching my video. This is the end.